Hello. Hopefully you were able to read the article on early understanding of equality, looking at the equal sign and thinking about the different ways we use it and trying to help students even in early elementary school to really understand the equal sign. In this video, I'm going to look at the relational perspective versus an operational perspective of the equal sign. So if you take a quick look at these, I'm not sure what you're thinking as you look at these. Some students, especially if they have an operational sense, are going to write 14 in this box. And that is problematic. Some of you might be thinking, oh, that's not problematic. That's 8 plus 6, that's 14. If that's the case, you have an operational view of the equal sign, and that is going to cause problems down the road, because you can see we want the equal sign to mean that the left is the same as, or the same value as, the right. And you can see in this example we have 14 here, and now 14 plus 8, this side is 22, and they're not equal, and so that is problematic. So operational perspective means the student sees it as an indication to do. So in this case, it was to add. In the next problem, someone with an operational sense would write 12 in here. And again, that's not accurate as well. And so what we need to be thinking about is this in a relational sense, that the relation between the left and the right side, that they have the equal value. And if that's the case, we can look at this and we can look at the structure, and we can see we have 8 here and here, so this needs to be 6. And similarly, we have times 2 and times 2, so this must be 6 as well. And so I just want to go through a few problems that you can see the difference between relational, or how the relational aspect can help. So if I've got 8 plus 12 equals something, either case will work there, operational or relational. We'll put 20 in the box. Same way, 5 times 3 equals blank. Either one will work. But when we start getting into problems like this, 2 times 6 equals blank times 4, that starts to look different. Relationally, we want them to be equal. I see that 4 compared to 2 is twice as big, so I'm thinking this number must be half as much as 6. So I can relationally think that through without actually multiplying 2 times 6 and getting 12. And that's really algebraic thinking that we want to build in our students. Another example quick, we've got 12 minus 5 equals blank plus 5 minus 5. Couple of different ways to look at it. Some of you might be thinking, oh, this is 0, so this needs to be the answer here. That works, that's 7. You can also see I have a minus 5 and a minus 5, so this value needs to be the same as this value. So if I put 7 in here, that's going to give me 12. One last example, 3 plus 4 plus 8 equals 3 plus an unknown. And if we use a structure here, we can see the 3 and the 3. So this part and this part must be the same. So this has to be 12. So just a few thoughts on relational versus operational. Often we don't mean to, but just working with young students, working on times tables or multiplication tables, we end up with an operational view that whenever they see the equal sign, they think they need to do something, versus relational, in which they understand how the two sides relate and that they do have the same value.